Okay. So hello, everyone. I'm here with Warren Chung today. So Warren is the president of Well Resources Inc. He specializes in assessing the commercial readiness of novel technologies, project development, and process licensing. Mr. Chung developed best practice protocols for various technologies and promotes the worldwide adoption of clean tech, particularly for the petroleum sector. He holds a Bachelor of Science degree with distinction in chemical and biomechanical engineering from the University of Alberta and is a registered professional engineer in the province of Alberta. So you can get away now.
All right, perfect. So first off, I want to thank everyone in our audience for joining this technology showcase today, and I hope you found the conference programming insightful and helpful. I also hope that everyone is staying safe as we all work together to get through these difficult times in dealing with COVID. With that said, what I'll be discussing today is quite timely, given the collapse in demand for petroleum in a lockdown economy and global efforts to push for decarbonization, or what they call the green recovery. Today, we'll be focusing specifically on one of the technologies developed and licensed by Well Resources, the SELEX platform, in a presentation I call Cleaner Oil, Fewer Pipelines, More Value. So just a brief overview of Well Resources and what we do. Well is a 100% Canadian-owned company operating out of Alberta, Canada, with satellites in Vancouver, Beijing, Guangzhou, and Qingdao, China. We focus on the development and process licensing of green, clean, and safe technologies in the petroleum sector. And our primary intent is to help our clients move the needle when it comes to adopting processes that benefit health, safety, and the environment. Increasingly, companies, investors, and society at large are demanding that we move towards more socially and environmentally responsible ways of doing things. And certainly, our SELEX technology will play a vital role in that energy transformation. With that said, SELEX is just one of the offerings in Well's portfolio. Another one of our commercially proven technologies is ionylation, which is a composite ionic liquid catalyzed alkylation technology that produces clean fuels while eliminating the industry's reliance on harmful, toxic, and corrosive acid catalysts, such as concentrated sulfuric acid and hydrogen fluoride. But back to SELEX, this is what we call a bottom-of-the-barrel processing technology, where we regularly deal with the heaviest, most carbon-intensive, and contaminant-rich petroleum constituents. And just so that everyone has the same baseline, in a nutshell, a refinery is an industrial facility that aims to organize the raw, unprocessed oil into various constituents, typically by boiling range, and then removing various contaminants so that the finished products, such as gasoline, diesel, and jet fuel, meet minimum consumer specifications set by the government. So here in Alberta, we sit on a world-class energy resource. Oil and gas from the Western Canadian Sedimentary Basin has provided this province and its neighbors vast opportunities and wealth over the years. In 2013, Alberta produced roughly 2.5 million barrels per day of crude oil, with an overwhelming majority of that production being attributed to the oil sands. In March 2020, just before the pandemic began impacting the North American economy, and despite the oil pricing downturn just a few years prior, Alberta actually managed to grow its daily production to almost 3.6 million barrels per day. In the months after the onset of the pandemic, production declined by roughly 20%, but has since ramped back up to near pre-pandemic levels. So despite the historical pricing volatility and short to medium term impacts of COVID-19, there are a number of pressing issues that need to be addressed, or at least considered, if we care about preserving and growing our local petroleum sector. And unless we can address them head on, these issues will always loom over us. In fact, these issues will only become worse and their impacts accelerated as society pushes for a lower carbon green future. So just to set the stage, let me describe the current situation to you. The petroleum industry in Canada likes to promote the message that we are one of the most responsible petroleum-rich jurisdictions in the world, with regulatory and environmental controls that make us the gold standard for clean and responsible resource exploitation. And for the most part, this is true. When we look at the per barrel carbon emissions attributed to the extraction and transportation of our oil resource, we are among the lowest. However, the majority of Canada's oil production is actually destined for sale to foreign markets in an unprocessed form, so the industry typically does not factor the downstream carbon emissions into the discussion. Environmentalists, on the other hand, are typically speaking a completely different language. When they talk about the carbon intensity of oil, they are more concerned about the full life cycle carbon emissions attributed to the barrel, which includes extraction, transportation, refining, as well as end user combustion. So in this regard, they're also right when they categorize Canadian oil as being more carbon intensive, and this comes down to the basic chemistry. So with that said, let's just take a look at what we're dealing with. Crude oil, as we know, is a complex mixture of hundreds and thousands of types of hydrocarbon compounds. The types and relative quantities of the specific compounds found in crude oil will affect the bulk properties and dictate how easy they are to transport and process into consumer-grade fuels and how carbon intensive they are. Heavy crudes tend to be more contaminant-rich and more difficult or expensive to process, and hence the pricing that it can command on the open market is much weaker than compared to lighter and cleaner crudes. In this image, I show the boiling point distributions for 3 different types of crudes, and you can quite easily see that each is comprised of different types of boiling point materials. The brown, yellow, and blue portions at the top represent the fraction of crude that can be separated from the remainder using basic distillation techniques. These fractionated compounds are relatively light and can be processed using conventional refining techniques to be turned into clean transportation fuels. The remaining red and black portions are what we call the heavy non-distillable fractions, collectively called residue or resid, and this needs to be handled in other ways. As you can see, it's actually the oil sands bitumen that contains the largest proportion of high boiling point materials, meaning the petroleum constituents tend to be larger and more complex, and therefore more carbon intensive. I will, however, add the caveat that this carbon intensity criticism is only valid under the assumption that the entire barrel of oil is destined for the combustion fuel market. Another concern looming over us has to do with industry's environmental footprint and land disruption. So here we show a very nice looking steam-assisted gravity drainage or SAGD operation. You can see that the level of surface disruption is quite minimal. These operations extract bitumen from underground oil sands basins using well pairs. One well injects steam into the reservoir to mobilize the petroleum, and the other well is used for extraction. Our petroleum industry definitely likes to show images like this as the gold standard for responsible resource development. On the other hand, we also get images like this, which depict tailings ponds and large surface disruptions at mined oil sands operations. And as the next generation of problem solvers, I think this is where we should be focusing more of our efforts into the future. There are over 250 square kilometers of tailings ponds currently in Alberta, representing billions of dollars of environmental liabilities. Mined oil sands operators typically frame the discussion around mitigation and restoration, which implicitly assumes that you have already decided you are going to make tailings, as opposed to having a discussion around prevention from the very beginning. And the reason why these tailings largely exist is a direct result of the specific processing techniques currently used by the industry, such as paraffinic froth treatment, which are old and out of date. Lastly, if you've been following the political news and monitoring headlines coming from the Canadian oil patch, you've probably heard a lot about Keystone XL. A major pipeline company based out of Calgary currently operates the 590,000 barrel per day Keystone pipeline, and they have been trying to build the Keystone XL pipeline expansion for more than 1 decade. In 2020, the UCP government stepped in and bought a $1.5 billion equity stake in the Keystone XL project, backed by another $6 billion in loan guarantees. However, on the day of his inauguration just last month, President Biden, as one of his first actions, issued an executive order to cancel the Keystone XL pipeline permit, effectively killing the project in its tracks. So a lot of people in the Canadian oil patch have huge concerns over this action, as it effectively places restrictions on our ability to export additional volumes of oil to the market, hence limiting our long-term growth potential. So in this section, I'll introduce you to something disruptive that can solve many of the previously mentioned issues simultaneously. First, let's examine the way raw bitumen is transported to market. The properties of raw bitumen don't actually meet minimum pipeline specifications for transport in Canada, particularly on density and viscosity measurements. It often needs to be mixed with a sizable volume of lighter hydrocarbon called diluent. This is the status quo, and in this image, you can see that diluent actually occupies a very significant volume in the pipe at nearly 30%. Under this scenario, you can also see that the carbon-intensive asphaltene portion shown in the black is also transported, taking up anywhere from 8 to 10% of the pipeline space. So what we want to do is look for ways to reduce or eliminate diluent usage in the most cost-effective, simplistic manner while improving the quality of our oil. And we can achieve this simply by first removing those problematic viscous and low-value asphaltene portions upfront within the province. In doing so, you reduce your diluent usage significantly and liberate up to 25 to 30% of pipeline space in existing infrastructure. Moreover, the clean deasphalted oil contains significantly lowered contaminant levels, meaning that the carbon intensity is reduced, and it becomes more valuable and easy to process feedstock for refiners. A major benefit of this solution is that it doesn't require us to rely on regulatory approvals for new pipelines or deal with political fallout in other countries, making it a solution that puts Albertans back in the driver's seat. I think it's seriously worth considering whether existing pipeline infrastructure is actually already enough for our future needs, as long as we are smart about what we decide to ship down those pipes. And from where I'm standing today, I can tell you with great confidence that there's some very easy low-hanging fruit that can disrupt the sector in a positive way. So how do we achieve this? As you might be able to guess, the solution is WELL's SELEX process, which stands for selective extraction of asphaltenes. Inspired by the decaffeination process, this technology is backed by over 30 years of research and development and is now commercially proven. Globally, there are 5 SELEX units already commissioned with a total installed capacity of 36,500 barrels per day, with the largest standalone unit having a resid processing capacity of 20,000 barrels per day. This technology is simple, it's low cost and low energy intensive. It's a supercritical solvent extraction process capable of selectively removing asphaltenes as solid granules unique to our process, making them very easy to handle and process further. As an aside, SELEX was actually originally developed with the intent to solve Alberta-specific issues, but with the slow pace of technology adoption in North America, we were actually able to license this technology successfully in Asia beforehand. So our hope is that the political and environmental willpower is now here that will allow our process to be used for Alberta's benefit. Here, I just want to show a simple process flow diagram of our process along with some real performance data. The table on the left shows 3 types of heavy crude oils being subjected to the SELEX process, and the results are quite shocking. Keeping in mind that our process only aims to remove the low-value carbon-intensive portion of a barrel, you can see that we achieve 100% asphaltenes separation each time, meaning that our process is targeted, effective, and reliable. In doing so, the remaining cleaned oil gets a modest API uplift in every case, meaning that the crude becomes less dense and implicitly more valuable. You can also see that contaminant levels such as sulfur, nickel, and vanadium are greatly reduced in the cleaned oil, and these contaminants are typically concentrated in that asphaltene portion. In terms of utilization in Alberta, here's a very high-level overview of one scenario where we can envision SELEX being deployed. In this scenario, we envision a central processing facility that processes diluted bitumen from the field and produces a cleaned, pipeline-ready deasphalted oil product, as well as a solid asphaltene granule byproduct. This facility could consist of 3 primary units, a diluent recovery unit, a vacuum distillation unit, and third, a SELEX unit. The goal here would be to recover and recycle as much diluent within the province as possible while removing those low-value asphaltene portions that cause those transportation and downstream processing issues. A nominal volume of diluent would still need to be used to transport the remaining deasphalted oil, and the asphaltenes could be used within the province as a feedstock for value-added materials. Please keep in mind that this is just one scenario for implementation. It also might make sense to implement this technology in the existing refineries and upgraders throughout our province to improve the processing margins and lower the carbon footprint. And this takes me to the last segment of my presentation. At WELL, we believe that innovation has to be continual, and there's tremendous opportunity to utilize these asphaltenes in a new way. The industry standard is to simply treat asphaltenes as a low-value combustion feedstock, but we don't think that this is the right approach, especially in a carbon-conscious society. Where we can identify where people see waste and turn it into something useful, that's where I think we can generate the most value. And because we know that that granular asphaltene byproduct is unique to WELL's process, it's actually given us a great opportunity to get a head start on developing new uses for this material and unlocking value for our stakeholders. We can take asphaltenes and turn them into a variety of carbon-based products for non-combustion purposes, transforming them into mats, fillers, fibers. Our testing has shown that asphaltenes are free from volatile hydrocarbons, they're non-reactive, they're non-leachable, and they also have an affinity to absorb organic contaminants, making them an excellent candidate for use in agricultural land remediation, water decontamination, bioreactors, and other carbon products. So imagine this, not only are we able to clean up our oil, we also create an additional opportunity to diversify our sector by providing value-added materials to other industries, either within the province or abroad. And I think that that's something that's very special. Lastly, I just want to leave you with some final thoughts as we navigate the petroleum industry into a green future. First, technology definitely exists that can solve some of the immediately pressing issues facing the sector today, including tackling carbon emissions and pipeline limitations. To get there, it simply comes down to whether we as an industry want to be backwards thinking or by perpetuating the status quo, or embracing change and the role of new technologies. Next, as innovators, we need to have an appreciation for fundamental sciences in order to truly develop meaningful solutions. Oil is a mature industry and compared to other sectors may even be considered a sunset industry. Relative to other industries, not much money is actually being spent on the fundamental research, and I can tell you from our experience at WELL, we're still learning new things each day. And last, many of in our audience today are aspiring entrepreneurs, problem solvers, and engineers looking to make an impact into the future. While the notion of a green transition may cause some uncertainty in the oil patch in the short term, please don't forget that this is also a perfect opportunity for the next generation to think outside the box to drive real change. I've included a few references for anyone who wants to or receive a copy of this presentation afterwards. I'd be happy to share that. And if you have any other questions, please feel free to reach out to a member of our team and check out our website at www.wellresources.ca. And with that said, I want to thank you for your time, and I'll pass it back to Ro.
Yes, so now we enter the question period. So please, everyone, if you have a question, put it in the chat and I will be able to ask her. So the first question is, what is the pricing differences between these solutions?
The pricing in which context? Between the solution we're offering and the status quo? Or
I would assume that is what it is. I would assume that's the case.
Okay, so our process is built completely 100% with low-cost carbon steel, and the pots and pans that go into building our process are actually quite conventional. When we do the cost estimates, and this is also true after discussing with some of our commercial users in terms of when they're doing the screening for different processes, determining which process they want to implement. They have often opted with our process because you can receive anywhere from 70 to 80% of the baseline cost compared to other technologies. And from an operating standpoint, from an OPEX standpoint, we tend to be about 10 to 15% more efficient than the alternatives.
Awesome. So the second question is, how does this compare and contrast to partially upgraded bitumen process?
So that's a very good question. What our process is, it's a very simple concept. All we are doing is removing those lowest value carbon intensive portions of the barrel that we feel are inadequate for being turned into consumer fuels in the end market, either at the upgrader or the refinery. When you're dealing with partially upgraded fuels, the the um, the linguistics matter. So when we talk about partially upgrading a fuel, we're talking about increasing the quality of the properties of the oil in order to make it flow easier within down the pipelines without using as much diluent. Typically, other partial upgrading technologies out there will incorporate some type of thermal process to crack the heavier portions of the crude into lighter constituents. And what we feel is that that is very energy intensive, and from a carbon emission standpoint, that doesn't make sense. From the research that we've performed here at Well, in understanding bitumen and understanding the properties of asphaltenes, we think that it would be better suited to utilize these molecules and these materials in ways that are for non-combustion purposes, something more akin to activated carbon or turning them into carbon fibers for value-added purposes.
Awesome. The third question is, can you elaborate more on why technology adoption has been slow in North America?
Sure. I think that's a great question, and I think that there are multiple reasons for this. Time and time again, as somebody advocating for a disruptive technology, you'll probably hear the phrase, "I like your technology, and I'll gladly be the second person to implement it." And this first to be second mentality essentially means that the company that you're dealing with has an overly conservative approach towards adopting new technologies. It means that they want to see that technology is proven in their backyard before they do it themselves. And I think that this may be a prudent approach when things are stable, but it can leave you in a disadvantaged position when situations change. For example, when governments push for decarbonization. Particularly for industrial process-driven technologies, the capital investment to implement tends to be quite high as well, which means that any decision to proceed is even more scrutinized or slowed, and you also have to consider that capital availability. In Canada, it's very easy to look across the street and see what your neighbor is doing, take a look at what you're doing, you see that both of you are making a decent return on your existing operations, and say that that's good enough. In the United States, there seems to be a greater appetite for trying new things, and their system rewards some degree of risk-taking. And then when we look at other jurisdictions like China, where we've been successful, that's a whole new ballgame with tremendous opportunity, and that's where we've seen the greatest success. And the last point that I'll make is that from an Alberta-specific standpoint, we are in a very unique position because of the fact that we are resource-rich. Historically, when oil prices are high, the top priority is chasing the fast and easy money, producing as many barrels as you can, and shelving lower priority return on investment projects. And on the other hand, when oil prices are low, we go into a full cost-cutting mode with massive layoffs, budget cuts, and no longer having that capital available for those projects that would have otherwise yielded better returns in a low-price environment. So from a purely economic standpoint, the window for implementing these types of projects tends to be quite narrow. However, when you now consider regulatory and environmental factors, which society is placing increasing importance on, you suddenly strengthen the case for embracing that change because the priority is no longer purely profit-driven, and that's where we are right now.
Perfect. So the last question, and then I think we'll have to end it there, is what is the difference between your process and the other bottom of the barrel processing technologies on the market today?
Sure, and that's very similar to the second question that was asked, but in a nutshell, Our process is both more energy efficient and gives you a cleaner and deeper separation compared to, say, a traditional solvent deasphalting technology. From a technical standpoint, the selective extraction of asphaltenes process is what we call a supercritical solvent extraction process, meaning that we subject a liquid feed to a circulating solvent at supercritical operating conditions. And what we found was that at or near supercritical operating points, the solvent exhibits very unique characteristics that allows you to essentially precipitate the heaviest, dirtiest, least soluble portions of your oil out of your liquid feed. And then on top of that, from an equipment standpoint, we also have to have an extractor that is capable of moving the remaining liquid feed while simultaneously dealing with precipitated solids. And by performing your separation this way, what you get is a very clean and targeted extraction for the asphaltene component. Compare this to conventional solvent extraction processes, which operate on the principle of liquid-liquid extraction, meaning that all streams in and out of your extractor have to be in the liquid phase. And because your equipment is specifically designed to only handle liquids, it's impossible for you to run your process in a way that produces a solid byproduct. If you do that, what you'll quickly get is you'll get solids deposition and buildup on your packing materials and immediately plug your extractor, making it inoperable. Lastly, because of the nature of the liquid-liquid extraction process used by the conventional techniques, you also have some entrainment of your desirable compounds in your bottom stream and some undesirable compounds in your product stream, meaning that your product is never truly clean and your waste actually contains a very significant portion of valuable material, which will ultimately impact your process economics.
Awesome. Yeah, I think that's the last question. So that concludes this session. Thank you again, Warren, for all of this. Are there any closing remarks you would like to make?
Please enjoy the rest of the conference. I know that the conference organizers have put in so much hard work behind the scenes to make this a hit. So I hope you all enjoy it, and we'll see you around throughout the conference.
Thank you again. And yeah,